Welcome back. Let's do question 331. In the diagram, A, B, and C are the vertices of triangle ABC. T is the midpoint of CB. The equation of the line AC is 5x minus 6y is equal to 8. This is the line AC. The angle of inclination of AB is alpha. We managed to find that this angle is actually 108.43 degrees. We found that in question 312. Triangle DCT is drawn such that CD is parallel to AB. The lines AC and DT intersect at S. The y-intercept of AC, P, F, and R are the x-intercepts of DC, AC, and AB respectively. Alright, we want to find the size of angle DCA. So we want to find the size of this angle here. So what we can do, we can find the gradient of AC using this equation. Then after finding the gradient of AC, we can find the angle AFR. We can find angle AFR. Then after finding angle AFR, we can find angle A. And then if we check, angle A and angle DCA are equal because these are alternate angles. This line and this line are parallel, and then this is the transversal. So this angle and this angle are alternate angles. So we can start by finding angle AFR from this equation, and then after finding AFR, we can find angle A using the exterior angle of a triangle. This is an exterior angle of a triangle. Alpha is the exterior angle of a triangle. So we can find what? We can find angle A using exterior angle of a triangle. Let's find the gradient of AC. Then after finding the gradient of AC, we can find angle AFR. The equation of AC is 5x minus 6y is equal to 8. We can write this in standard form. Let's bring 6y this side, becomes 5x minus 8 is equal to 6y. Now let's write it like this. 6y is equal to 5x minus 8. Okay? And then we can divide everything by 6. Y is equal to 5x divided by 6 minus 8 divided by 6, which is y is equal to 5 over 6x minus 4 over 3. Right, so therefore the gradient of AC is equal to 5 over 6. Now we have the gradient of AC, so it means we can find the angle of inclination here. Tan theta is equal to gradient of AC, which is 5 over 6. Theta is equal to arctan 5 over 6, and then we get that theta is equal to 39.81 degrees, rounded off to 2 decimal places. So the theta we're looking for here is this. Let's erase this. Alright, the angle we're looking for here is 39, this one, angle 39.81 degrees. Now, we can find this angle A using the exterior angle of a triangle. So angle A plus 39.81 degrees is equal to 108.43 degrees. So angle A is equal to 108.43 degrees minus 39.81 degrees, which gives us 68. Oh, sorry, the reason here. We have to write the reason, exterior angle of triangle, right? And then 108.43 minus 39.81, that's 68.62 degrees. Okay, and then this angle and this angle are alternate angles, just like we discussed. These are alternate angles, therefore they are equal. So angle DCA is equal to 68.62 degrees. Since these are alternate angles, since CD is parallel to AB. Okay,